All right. So first things first. Gotta cancel this radical out of here. What am I going to do to cancel the radical? Exponent of 4. Very good. So the fourth power cancels the fourth root. And then 2x to the fourth is 2 to the fourth, which is 16, and x to the fourth. Okay with that? So to solve this, I'm going to subtract 3 and add 8x squared to both sides to get it equal to 0. Annalise? Yeah. Yes, you could do the other direction. Personally, I think it's a little bit easier if the leading coefficient is a positive number for my polynomial than if the leading coefficient is a negative. It's usually a little easier to do the factoring in that case, but there's nothing wrong with doing it in that direction. Jack, are we good to here? Okay. Did you get this far when you tried it? Okay. And then you were kind of stuck on what to do at this point? So this is a degree 4 polynomial, right? But it only has 3 terms. If I look at this polynomial, it is in the quadratic form, isn't it? Remember that from last semester? So this is something we can factor. Since the leading coefficient is 1, though, I have to find the two numbers that multiply to give me 16 times negative 3, which is negative 48, and then add to give me 8. So that would be 12 and negative 4. Are we happy with that? So what I'm going to use those two numbers to do is I'm going to break up 8x squared into 12x squared plus a negative 4x squared, and then make 2 groups. From the first group, I can take out a 4x squared. And from the second group, I can take out a negative 1. And then if I look, each of these terms contains the factor 4x squared plus 3. So I can factor that out. And I'm left with 4x squared plus 3 times 4x squared minus 1. So to solve this, I'm going to set each of these equal to 0. And what's going to be the easiest way to solve these quadratics? I would solve them directly because they just have x squareds. Good. So the first one, I'm going to subtract 3 from both sides and then divide by 4. And then I can square root both sides. Although what happens when I square root this one, I'm getting a plus or minus, but because I'm square rooting a negative, I'm going to get an I. So this part doesn't really tell me anything, right? Because I'm just looking for real solutions here, so I'm going to discard these imaginary ones. Is everybody okay with that idea? Okay. Similarly, I'm going to add 1 to both sides and divide by 4. And then I square root both sides. As had been mentioned, I'm going to get a plus or minus. So I'll have the square root of 1/2 and then the square root, or the negative 1/2. Is everybody okay with why the square root of 1/4 is 1/2? The square root of the top is 1 and the square root of the bottom is 2, right? Everybody happy there? Then I just need to check these. Negative 1/2 is going to fail my check. I'll ask you to trust me on that. You could check it on your own on your calculator though, pretty quickly to verify that. And positive 1/2 does work. Is that okay, Jack? Okay. So again, a little bit tricky because we had this old factoring technique that we had talked about first semester kind of crop up in this problem. But this is one of the reasons why polynomials are so important, is that many times these other types of equations turn into just solving for a polynomial, right? Many problems just kind of work their way down to being a polynomial solving problem. So those polynomial solving skills are kind of really fundamental because they become really the solving method for a lot of these kinds of problems that we're going to work with. Okay with that? Great. Who else has questions from the homework? Dan?
I have a bit of a problem.
Number 3? Sure. Okay. What did you do first here, Dan? Good. Squaring both sides is the same thing I would do first. And then what I'm going to do is I'm going to try to solve this quadratic. So the first step would be to get everything onto one side. So I'm going to subtract 16x and 225 to both sides. So what I need to do is find, if I want to solve this by factoring, which is what I did when I solved it. You could have used the quadratic formula too. That would have been fine as well. Is find two numbers that multiply to give me negative 225 and add to give me negative 16. Those two numbers are negative 25 and positive 9. Might have been hard to find those. They're kind of big. So there's my factored form. And then from there, it's pretty easy, right? I get 25 and negative 9. And the check for this is actually really easy. I don't even need my calculator. Because I noticed that when I plug the negative 9 in for x, I'd be having a negative is equal to a square root. And I know that can't happen, right? Square roots always give me positive answers. So I know right away that negative 9 is going to be extraneous. You would have to check 25 on the calculator to make sure that one also works, but it does. Does that feel okay?
Yeah.
Do you just have trouble with the factoring part?
Yeah.
In the case where you can't find the factors, you can always use the quadratic formula. So if you look at it for more than a few minutes and you're like, I can't figure out the factors for this, just use the quadratic formula. It's okay. The point of using factoring as my first option is usually because it's faster. But if you can't find the factors, it's certainly not faster, right? So if you try for a minute or so and you can't come up with the two numbers, just use the quadratic formula. That's fine. It still gets you the right answer. It's sometimes a little longer, but if you can't find the factors, then it probably isn't any longer, right? Who else? Questions from this? Okay. Can I have you guys